Hi everyone, this is Bowen. I will present our paper, Pointedly Supervised Instance Segmentation. This is a joint work with my colleagues Omkar and Alex. The task of instance segmentation requires an algorithm to locate objects and delineate them with pixel-level binary masks. Existing algorithms like mask RCN usually requires manual annotation of object masks for training. Collecting such annotation is usually time-consuming. For example, it takes on average 80 seconds to annotate an object in the COCO dataset. Weakly supervised methods use easier to acquire annotation. For example, image-level category labels or bounding boxes. However, current weak supervisions still have some limitations. For example, they are not compatible with existing fully supervised instance segmentation pipeline. And the performance is still considerably behind fully supervised counterparts, especially on large-scale dataset. In this paper, we propose a point-based instance-level annotation. For each object in an image, we annotate its bounding box first. Then, we uniformly sample several points inside the box. And for each point, we ask a human annotator to verify whether it is on the foreground or background of the object. With 10 annotated points per instance, our point-based annotation is more than 5 times faster to collect than masks. Our point-based annotation has several advantages over other forms of weak supervision. First of all, it is compatible with any existing instance segmentation approach. The key idea is to only calculate the mask loss, for example, a binary cross-entropy loss, on label points only. If mask coordinate is not aligned with the image coordinate, which is usually the case in a mask RCN style model, we use interpolation to get the prediction on each annotated point's location. Besides simple-to-use point-based annotation, it also gives strong performance. We find models trained with our point-based annotation achieves 94 to 98% of their fully supervised performance. Our point-based annotation also generalizes to different datasets with different scales as well. As shown in this table, mask RCN trained with our point-based annotation works well on COCO, Pascal VOC, cityscapes, and LWIS datasets. Our point-based annotation is also compatible with different instance segmentation algorithms. However, we observe more performance drop with the point rank model than mask RCN model. But why point rank fails to achieve a good performance with points? This figure shows how point rank works. It first predicts a coarse mask of very low resolution, usually 7 by 7. Then a point head refines the upsampled coarse mask using both point features and coarse mask prediction. As I mentioned earlier, training with point supervision requires interpolation, and we believe interpolation leads to noisy training signal due to the mask loss on the coarse mask prediction. We address this issue by getting rid of the coarse mask prediction. For each instance, we predict the parameter of the point head and directly use point head to predict the point level mask at an arbitrary point location conditioned by its coordinate. Our experiment shows the implicit point rank significantly improves performance under our point-based annotation. In summary, we propose a point-based annotation for instance segmentation, which consists of a bounding box and a few randomly sampled points within the bounding box. Our point-based annotation is compatible with any existing instance segmentation approach. And using 10 annotated points per object can achieve 94 to 98% of their fully supervised performance. We further propose an implicit point rank module motivated by the new point-based annotation. All code and models are already available on GitHub. Please check our paper for more details. Thank you.